Hi folks, we're going to get some practice simplifying by factoring out the least common power. This is something we kind of avoided in Chapter 3 so that you could get used to using the product rule and the quotient rule and the chain rule. So we didn't simplify completely, but for Chapter 4 we need to be able to do this, and you probably aren't familiar with how to do this, or you've done it very little. So first I'm going to find the derivative. So I'll rewrite. And we have f of x equals x squared times 1 minus x squared to the 1/2 power. And then I'm going to take the derivative, and then we'll practice the factoring. F prime of x equals, and first factor, second factor. So we have product rule, first x squared times the derivative of the second factor, using the power rule, bring the exponent forward, rewrite the base, take 1 off the exponent, and now we want the derivative of the base. So that's our first times derivative of the second. Now plus the second factor times the derivative of the first factor, which is 2x. So now we have the derivative, and for Chapter 3, that's where we stopped, just so we could get that practice, but we need to practice going a little further now. I can cancel this 2 with this 2, because one's a numerator and one's a denominator, and right here we have a string of multiplication, and then this plus separates us into a different term that also is a string of multiplication. So there's 2 terms separated by this plus. I'm going to do something different for a moment and just remind you what's really going on behind the scenes when you factor. So to factor, let's say 4x cubed plus 7x squared plus 9x. And you all know how to do that. You take out the greatest common factor, which is an x, but what's really going on there is that you're multiplying and dividing by the greatest common factor. So you are factoring on x, and then here's the original equation, or expression, and we multiply by x on the outside, and we divide by x on the inside, and usually we just do that in our heads. So you get x times 4x squared when you subtract the exponents, plus 7x when you subtract the exponents, plus 9 when you cancel the x's. So we will use the same technique up above. I'm just going to put this in a box so it doesn't look like a step. And for now, looking up above, this term and this term, we want to take out, well, maybe we'll rewrite it first. Let's rewrite. And then I think you'll see it a little bit easier. So f prime of x equals, and we have a negative, and we can put it in front from here, x squared and an x, so that's x cubed, and then 1 minus x squared to the negative 1/2 power. And then the next term, plus 2x, will bring to the front, and 1 minus x squared to the positive 1/2 power. So now I can just refer to this, and my greatest common factor, GCF, is equal to, looks like it's x times 1 minus x squared, because they both have that. And remember, just like up above, we took out the lowest power of the x's. So now we're going to take out the lowest power of the 1 minus x squared, and that's negative 1/2 power. And now to compute it, we'll go ahead and multiply and divide by the greatest common factor. X times 1 minus x squared to the negative 1/2 power. The original equation. Positive 1/2 power. Divided by the greatest common factor. So this is a technique you can use when it's more complicated. You have fractional exponents or things are just kind of not as familiar. So moving up, I'm going to have my greatest common factor on the outside. x times 1 minus x squared to the negative 1/2 power. On the inside, I have some reducing, and so we subtract the exponents. So with the x's, x to the 3 minus 1 power is going to be negative x squared, because we have a negative going along for the right in front. And then this will be 1 minus x squared to the negative 1/2 minus negative 1/2. We're subtracting the exponents. Upper exponent minus lower exponent. And then the next one, plus 2, the x's cancel, and that will be 1 minus x squared to the 1/2 minus negative 1/2. Okay, and so really these two we could have just canceled. Certainly we could have canceled, but I just want to show you a little bit more what happens if you don't, and that you're subtracting the exponents, and that now we're working with fractions. So we have x times 1 minus x squared to the negative 1/2 power. And then this will be negative x squared times 1 minus x squared to the negative 1/2 plus 1/2, and that's 0. So this whole thing becomes 1. And then plus 2 times 1 minus x squared. And now this is 1/2 plus 1/2, so that's to the 1 power. Moving up. Give me a second. I can't quite make this fit on the screen, so I'm going to fold the paper. Okay. So certainly I'm showing lots of extra steps, but I want to make sure you know what's going on. So we have now x 1 minus x squared to the negative 1/2 power, and then we have negative x squared plus 2 times 1 minus x squared. And we can distribute the 2. And we can get rid of the negative exponent, so that will move to the denominator. So this is going to give me a fraction. In the numerator, I have x on the outside. I have 1 minus x squared to the 1/2 on the bottom, which we could write as a square root, certainly. And then in the parentheses, we have negative x squared plus 2 minus 2x squared. So that's going to give me, moving up, x times, combining like terms, negative 3x squared plus 2. Over square root of 1 minus x squared. All right, and they're really not this long. I'm just showing a lot of extra steps in there. The main thing that you want to remember, let me just get that back, is when you have to factor something out and you're not quite sure how to do it, you're taking out, they both have 1 minus x squared, so you're taking out the 1 minus x squares and you're doing the lowest powers. Same thing that we did with the x's. They both had x's, so we take out an x and we do it to the lowest power. And then if you're not sure what you get, take it out like you normally do, but on the inside, rewrite the original expression and divide by the greatest common factor. And that'll get you there. All right, I hope this helps. Certainly let me know if you have any questions. Have a great, fantastic, wonderful day.